controlling stake in. The most noticeable, if you were familiar with Siemens of 2019, and was the Siemens Gas and Power has just recently been spun off into a portfolio company where Siemens has a controlling share of that, but we are now publicly listed under Siemens Energy. Go forward again. You know, just to kind of give you a little bit of context relative to the full set of offerings, you know, this slide does a great job in terms of highlighting all of the areas we play in, right? So we all commute in cars that, you know, could have been designed on Siemens software, which were all likely built in factories that incorporate some of our automation technology. And as we look forward to the future, you know, those vehicles, and as we continue the shift to electrification, are likely going to get charged by renewable and decentralized Siemens smart grid energy and technologies. So, you know, we're really prevalent in almost every asset of your day-to-day lives, albeit sometimes not known to you. So as I mentioned earlier, we're roughly 300,000 employees with close to 60 billion euros in annual revenues. So rather large organization, and I'll go through the business units here on the next slide to give you a sense of how we structure ourselves. So Digital Industries, headquartered in Nuremberg, Germany. This is really you know, a group of technologies and businesses that are really focused on manufacturing operations and automation technologies. So this includes factory automation, process automation, motion control, but it also includes the group that I'm responsible for internally, which is Digital Industries Software, where we've got an entire portfolio of software solutions that help manufacturers develop their products and then manufacture those products and bring them to market. Next slide. We're roughly, I think, just under or just over 16 billion euros and 76,000 employees. Note that all of these figures are prior to the reorg, going back to 2019. Next slide. From a smart infrastructure perspective, this organization is really focused on delivering solutions that encompass a complete portfolio of building technologies, along with robust energy solutions, including low and medium voltage power products, headquartered in Zug, Switzerland. And, you know, pretty similar size, if you want to go forward to the next slide, to Digital Industries, both from a number of employees as well as their annual revenue turns. Next, and Siemens Mobility, headquartered out of Munich, Germany, and really kind of forming, you know, the basis for the conversation and rest of the presentation here this morning is really focused on the application of digitalization to enable intelligent infrastructure, enhanced customer experience, and increased value to transportation providers on a global basis. Almost 37,000 employees and close to 9 billion euros in annual turn there from a revenue perspective. So you probably heard me say digitalization and intelligent and smart over the last number of slides quite a bit. You know, really this graphic just takes a different perspective, and rather than a business unit focus is really around how Siemens has embraced digitalization to transform our own organization. So, you know, the graphic on the left kind of gives you a nice clean view of all of the areas of the business where we apply digitalization and software solutions to hardware in order to, you know, bring value to our customers. So whether it's digitally optimized electrification, you know, embracing IoT and all of the possibilities of near real-time information and what that can do to drive more efficient operations, to all of the specialized services that need to support your own organization's transformations and transition over into digital technologies. So one note, again, being a software-centric personality here speaking to you all, you know, probably little known fact that Siemens is now globally one of the top 10 largest software vendors on a revenue and employees basis here. So we are the only software vendor in that global top 10 that's really focused on industrial and operations-based type solutions. Go ahead. And finally, just to give you a quick snapshot of Siemens in Canada. Siemens Canada is headquartered out of Oakville, Ontario, where I find myself. And you know, in 2019, roughly $2 billion in annual sales. So we've got a pretty significant presence and impact on the local economy. 46 facilities, which includes 11 manufacturing sites and almost 4,000 employees. So that's it as far as my introduction to Siemens is concerned. If there's other questions that I can answer at the end of the presentation, be happy to. But at this point, I would like to transition over to Ray.
Ray, we have audio issues and we're not seeing your presentation.
Hey, thanks, Roberta. I've been clicking quite a few buttons, everyone, and I'm wondering if you're able to see my screen now.
Yeah,
yep,
we've
all
got
good.
mega trends. Yep.
Hey, thanks. It's really great to be here. And, you know, the first thing on my agenda was to make sure that everyone could see my screen. So thanks for confirming that. And can everyone hear me okay?
Yep, your audio is good. Thank you.
Excellent. So I get the opportunity to be here with you to talk about trends in electrification. And really, it's these global trends that have brought us together. So I just thought I would pay tribute to all of the change that's happening across the globe today. And these megatrends really lead us to a topic about sustainability. And I'll take this opportunity just simply to position the trends that I intend to talk about on the next few slides. But the reality is that the global megatrends that we just witnessed led us to a worldwide conversation about sustainability. And this is where I was introduced to the zero emission space. And I became passionate about sustainability by extension of my experience at Royal Roads University, where I did an MBA. And being a good right-wing Ontarian, I spent a couple of years with some tree-hugging MBA folks and left that program really having the experience of being enlightened to sustainability. But I would point out that sustainability has really become synonymous with zero emissions. And by extension, zero emissions has equaled electrification. And I would also just draw your attention to the pendulum that I have in the bottom left corner of the screen, where we have carbon on one side and zero emissions on the other. And really the goal of sustainability is just simply to get to the zero carbon footprint position. And emissions, the conversation about emissions really is driven by those extreme folks who talk about zero emissions. So I guess my request today of this group is reach out and hug a zero emissions person. They're trying to move that pendulum. And the second thing I would ask of this group today is potentially to consider some of the things that you're doing at home or at work with respect to sustainability. You know, the first trend that I wanted to talk about was respect to fleets. I think most of us on the call today are involved in fleets in some way. And if there's any New Flyer folks on the phone, they're certainly aware of this green line. New Flyer has been a leader in the e-mobility sector in the mass transit industry. But for the rest of us, we're probably in the light, medium, and heavy commercial fleet areas. And you can see that the trends of adoption are a little below the mass transit sector. So with that in mind, my own personal opinion is that these trend lines are in between here, this slide that's Bloomberg originated, and the next couple of slides that I have that really indicate a much faster adoption related to electrification, and I'll talk about that in a little bit. But for you Malcolm Gladwell fans out there, I think we'll find a tipping point here in 2022 where we can see that the electric car is really becoming price equal to its internal combustion engine equivalent. And with respect to that, we are already seeing Porter's five forces play out in the market and in industry. And what I mean by that is that there is entrance of new players to the fleet industry. For example, Siemens on the electrification side, we're absolutely a new player in the fleet industry from electrification perspective. But I would think acutely, beginning in 2022, the first bottleneck that we as an industry are going to see is related to human resources. And I don't mean just training. I mean that in 2022, as the tipping point for automobiles, electric automobiles, personal automobiles begins, the fight for human resources to provide all of the engineering, all of the services, all of the supply chain related to any vehicle is going to become tight. So my advice here is to hire good people out of university now and pair them with an old timer that's been around your company for a while, but by all means, give them something electric to work on so that you can keep them in the future. So that's really the point that I was trying to make with this trend. Interestingly, and I will talk more about charger types a little later when the presentation gets a bit more technical, but here is another study indicating the adoption rate of the types of chargers that we see across the electric vehicle industry. And really, I'd like to draw your attention to two charger types that are indicated on this slide, the CCS and the others. And the reason I'm drawing your attention to those two pieces of information is that I see those charger types applying to us, the people on this call today. The CCS and the other types I will describe, but you can see on this slide that the adoption rate is very significant across the business and very quickly. And my theory here is that Bloomberg surveyed manufacturers on fleet adoption rates and came up with those curves that we saw earlier in the presentation, whereas here they're surveying users, and this is more indicative of the demand related to these types of chargers. A presentation of mine isn't complete without a little humor. So I hope that you find humor in this slide, but the point is that the trend in electrification is that there's political utility in discussion around zero emissions and electrification. And as fun as it is to have these conversations at the dinner table, the fact is that shareholders are listening here, customers are listening here. And I also included this slide partly to highlight my own experience with the political utility of electrification. Just a few years ago, I was hired by a company to help them out on the electrification side of their business. And I had a client-facing role. This company was a bit of a laggard in the electrification side of their fleet. And what was happening is that their customers were disengaging with them because they had no clearly articulated path toward zero emission or electrification. And even though electrification made up less than 1% of the market at that time, clients became no longer interested in speaking with them about traditional products like diesels or hybrids because there was no clearly articulated path. So this is really an opportunity to develop a profitable story for your business around zero emissions, and that probably means around electrification. And on that note, I think it's important just to touch briefly on the trend of change, particularly as it relates not just to sustainability and electrification, but how it is a change in the way we look at how fleets operate and the adoption rates of clients. So for those of you who don't know Cotter, it's a very easy and short book to read about change and the process that we go through for change. But the fact that you're at this session indicates you are already a leader in zero emissions electrification. And even if you came to this session just simply to prove to yourself that there's nothing real new about electrification, our own personal journey towards sustainability and zero emissions begins by asking ourselves intelligent questions related to electrification. And at least for me, that's where my zero emissions journey began. So I would encourage you, yes, I asked you to consider about your own sustainability goals, but I would urge you on a corporate level to consider where is the low-hanging fruit and create some success stories around that. I've included some examples here on this slide related to stop-start technology, mild hybrid, and socializing the idea of electrification throughout your organization. And when you get those early wins, it's important to trumpet those wins. It's important to shout them from the rooftop. And it's good for your morale, your employee morale, of course. I mentioned those dinner conversations, but your clients are also watching and your shareholders are also watching. And of course, later on in the presentation, I know Kyle is going to speak a little bit more technically about these trends. And so will I a little later on in the slide deck. But being a right-wing capitalist myself, I do like to rely on facts, and I realize I haven't included many graphics on this slide, but it is highly factual. And in the slide deck that Ron will distribute or make available at the end of our session, I've included links to all of these points, and you may wish to access these because there's some interesting factual information in there. But the fact is that the trends are nice to talk about, and I do start with one. I think everybody knows about the Greta Thunberg movement, but the Guardian reports that 40 million people have marched to that theme so far around the world, and I think that for me is astounding. But bringing it closer to home, I think everyone knows Canada has signed on to the Paris Climate Accord. And really, I think that's our first indication that carbon is absolutely going to be commercialized. And there's evidence of that taking place in Canada today, where we see that there are 100% write-downs of capital assets in the first year for industrial electric vehicles. And I say EVs, I mean zero emission vehicles. And of course, there's personal tax credits related to carbon that we see on our personal tax returns today. So I think there's evidence here that carbon is going to be commercialized. And moving further along this slide, I talk about the infrastructure subsidies. For those of you that paid attention to the throne speech, there was mention about the quote unquote Green New Deal. I think we're all influenced by that vernacular. But the fact is that the government today is working on a plan to electrify 5,000 buses, school and transit buses by 2025. And the Canadian Infrastructure Bank is supposedly going to be the financing mechanism for that tool. And like I mentioned, there are links in a slide that I have hidden in this deck, but will be accessible to you. Speaking about our big brother down to the south, there are so many different funding mechanisms. I haven't included them all here. There's so many movements across the United States and obviously a much bigger market than Canada. And my slide even, I built this slide maybe a month ago. These 13 states that have adopted the CARB regulations, that's the California Air Resources Board regulations. I believe that count is now 17 states have adopted this. And California and those other adopting states have incorporated programs to support the rollout of electric vehicles. I've named a few here, and some of them are federally funded, some of them are state funded, some of them have matching funds from federal, state, municipal. But the point here is there's at least 3 programs with substantial millions and in some cases billions of dollars available for the subsidization of zero emission fleets, including electric vehicles and other types like fuel cell, for example. For those of you west of Thunder Bay, you might not have heard that Ontario recently, like in the past couple of weeks, has announced a couple of automotive plants, both developed through government funding programs. Ford in Oakville and GM in Oshawa have announced electric car programs. And of course, the discussion about carbon and zero emissions isn't complete without recognizing that most major cities across North America and obviously Europe, the developed world is really what I'm talking about here. Most of them have drawn a line in the sand where they intend to be carbon neutral or have implemented zero emissions regulations. And that really is the power behind the trends in electrification. So with that, I'd like to turn it over to my colleague Kyle Ferguson, who's with our commercial vehicles group. And the presentation is decidedly more technical from here on in. I hope that we were able to engage you in vehicle electrification, in zero emissions, and in sustainability. And I hope that you enjoy the rest of the presentation. Kyle?
Hello, everyone. Can I get a confirmation that you see the slide deck as well as the audio is okay?
Yes, I can confirm both. Thanks.
Excellent. All right. Very nice to meet everyone. I'm based out of the United States, normally in Dallas, Texas. Currently spending some time in Houston. I represent the commercial vehicles business unit within Siemens. You remember that very first slide deck. We fit within that portfolio of companies, but are a joint effort of 2 business units that were actually historically within that mobility unit. So Siemens commercial vehicles perspective, in 1985, we were noticing the trends of vehicle electrification, particularly the bus. And that's when we really hopped on and started trying to capture that market. In the very first generations of our systems, we were using basically rail technology, applying that to buses. And then we moved on to taking the next step of those rail components, minorizing or miniaturizing or just kind of making them a little bit more mobile for smaller vehicles. And second generation of our product portfolio where we have a really large install base. And then in the last couple years, we've moved on to the third generation, trying to incorporate more automotive ideals and expectations of certifications, specification, and just general sizing. On the top of this slide, I want to bring attention also energy source. We'll be talking today about a lot about propulsion and the powertrain, drivetrain of the vehicles and some of the technical aspects of that. But I think it's important to note it over the 25, 30 years that we've been focused on the electric vehicle space, power sources have come, but none had actually gone. Hybrids themselves, if you ask our highest management, we see hybrids as it's slowly phasing out over time as battery electric vehicle price points come down closer to the conventional power source counterparts. But there still remains times when a hybrid does provide a lot of value, and particularly if the environment is very cold or very warm, and the load required to actually make your passengers comfortable perhaps would require a whole generator set to do so. We look at battery hybrids and fuel cells as the future, infrastructure being a large portion of what decides that. But I think the message for me to y'all today is that as you are looking at electrification of your vehicle, you realize that there's not one size fits all solution in terms of energy source. We as a manufacturer of propulsion powertrains focus on being agnostic, and I would certainly recommend that you design a system that doesn't tie you into one or the other, unless you're really feeling that's the way to go and that's the way you want to position your business. Siemens, for perspective, we manufacture traction motors and inverters for commercial vehicles. We have over 100 trucks installed, which you can see from earlier trends, the slow adoption rate of that, but it's actually a market that's very hot right now, and certainly the early adopters are starting to give way to the early movers. And then buses, we have a large install base, over 15,000, multi-millions of miles in place, and that really matches the trends that you saw earlier, with buses being the initial, the first movers, early adopters. Real quickly, we are certainly very flexible and power dense in our components. We try to be, we are power source agnostic, and we are certainly a company who's well positioned to handle a high volume production, basically partially because of our consistent components, as well as just being a manufacturer in this space for a long time, and being used to high volume production in all of our other business units. Couple of points right here on the product itself. Direct drives versus transmissions. So not obviously, if you would like to have the most efficient drivetrain, directly driving your differential and your axle from a motor, and then powering that motor with a battery is the most efficient way to do it. But that's not always the only way to do it, as the transmission may be necessary to hit certain requirements, whether that be vehicle speed or the torque required based on the vehicle weight. Within the inverters, we try to focus on integrating the controllers within them, one less component, a couple less wires, maybe some fewer cooling hoses, makes that footprint of the electric system smaller. And then with the motor design, we focus on having a modular frame size, which means that the mounting positions can be very consistent. So if you have a smaller motor requirement, smaller traction effort requirement, the shaft height and the distance from the front bolt hole to the shaft end is the same, whether that's the smallest of our motor designs or the largest. And that really just makes it easier to integrate within the chassis. And then we also have multiple windings available for our motors, which we'll talk a little bit more, but essentially it's you're getting more power and torque out of the same frame by adding a second winding. You see that our large install base is within buses, but it can be more than that. The trucks itself, certainly a lot of applications can be brought as, particularly like terminal trucks or any sort of I guess vehicles that are used in ports, as well as high logistic areas, as well as into the garbage trucks, being one is a very hot application right now. My business unit perspective, we've also done underground utility vehicles, have a tethered solution with Sandvik. We have an underground scissor lift with Timberland, formerly known as Marcotte. The one you see on the picture is a diesel version of that, but I actually received word that our electric version is now going into the field. So mining is absolutely a industry that's heavily looking at electrification. And on the top you see a couple of the large trucks or drag lines or shovels that we support with some of our traditional mobile mining equipment. So looking at the application itself, the key here is on the left, the grade ability versus vehicle speed. We call this a traction effort curve. So when you're in discussion with someone about changing from a conventional power source propulsion to an electric propulsion, this is the chart that you need to get. It allows you to see just how fast you can go at what grades, and that defines how the performance of your vehicle, and that's something you can actually compare to the existing performance of your vehicle. After we define a traction effort and vehicle performance, similar next steps in the integration would be to really select the equipment, size it, the quantities of it, and then we also want to focus on defining a stakeholder specification document with you. So when you're going from conventional to electric, you want to understand who all is involved and what is their role, because if you do not clearly define that and assume, then there's a greater chance of something being missed and project targets being missed. So this is a kind of a data sheet into the motor, and kind of walk through a little bit of what you're looking at, because at the end of the day, this is not a direct crossover between a diesel and an electric, and really that comes from the high availability torque at the lowest speeds of the motor design. So I highlighted, circled here, some of the basic specifications that you would want to achieve. Obviously, weight and dimensions are very important. Being able to fit, so we call this a power density. Ambient temperature, so you want to make sure that the motor is capable of functioning in both high or low temperatures. You want to make sure you have a high degree of protection, so if water splashes up on the motor while in operation, you're not worried about ingress. And then I also highlighted here speed. Notice the maximum speed of 3,500 is much lower than the 5,000 or 6,000 you might see on a conventional engine. And that's just because we don't need to go that high to generate the torque and power required to meet the traction effort. So right here you see the max torque. So this is an instantaneous amount, hold for a short period of time, let's say a couple of minutes. And we would use this to really get the highest climbing ability from start. This is a number that sounds very nice, the higher you can go. So when you're evaluating propulsion suppliers, you want to certainly make sure you understand whether that's the max torque or the rated torque, which is much lower here, but that's something we can provide continuously. So if you're at a slow crawl and driving and you press the gas pedal more and you need to gain speed, you want to have that high peak torque to be able to start that hard rotation and that higher torque pull. But you need that continuous torque to be able to climb and accelerate for a longer period of time. As we look into acceleration, we start talking about the power available, and this is the max power. And I'll go ahead and highlight the max 30-minute power, or closer to a continuous power. And you can see there's a less steep drop-off, but that's because it is the power associates to the higher acceleration and a continuous application of torque. As torque would imagine being a breakthrough of energy to.
Kyle, we've lost your audio. Oh, we've lost your audio.
Is this better?
There you are. Yep.
Hey, sorry. So I'm on short on time, so I'm going to keep moving here. But I just wanted to point out that these are the certain terms regards with evaluating a motor itself. When you are applying these motors to a vehicle, you'll see here this DC bus at 600, 700 volts. That's a very important thing that you create with an electric vehicle, is this common bus, as that allows you to drive your main propulsion driver or your auxiliary loads. I have two options here, and this demonstrates a single and a double winding motor. Double winding being a second inverter to drive the second set of windings in the motor. In this instance, we are driving a single direct axle, and we call this a direct drive. The next step to this would be adding a second motor for driving a second axle, and then possibly adding a second winding on that second motor for a total of 4 inverters per application. One thing to highlight here is not only we focus on this propulsion system and the auxiliary system, let's say 80% of the control required within an electric vehicle, but there is also an overall vehicle controller, which we would probably recommend to be very similar to your existing vehicle, as well as there's a battery system. And the best thing I can say is that the battery manufacturers understand their product and the battery management systems the best. So when you're defining the stakeholder specification document, having someone like myself and someone from a battery manufacturer together will certainly make sure that everything goes smoothly. Proceeding on to vehicle software, this is what kind of helps make the transition of conventional to electric the same. Creepage function being that crawl you get once you take a engine out of park into drive and you start moving forward. We simulate that with the creepage function. That helps make sure that drivers feel more comfortable. We do offer hybrid control software, certainly a more intense integration process, but it is kind of making that communication of when the vehicle stops. One thing I want to add is when we're talking about vehicle control, one thing that we look at is when you apply the brakes to a vehicle, our drive control software says, all right, this needs to be turned into regeneration energy, and we brake through regeneration, or this is an emergency, the battery is too full, we need to actually apply the mechanical brakes itself. I circled here the EVCU to try to highlight what we would consider an OEM requirement. This is something that you understand best as you understand your vehicle. Quickly into the inverters. What we have two right here, one for the asynchronous motor, one for permanent magnet motor. Permanent magnet being the kind of the way of the future as we see it based on their power density and control abilities. This voltage protection module is a safety function that allows us to basically prevent a counter torque being applied to the motor in the event of a high vehicle state. Certainly a conversation for much deeper a topic for much deeper conversation. I want to highlight the voltage here. This being again tying into the voltage DC bus. These are the standards of the industry as we find this 800 volts up to 800 volts down to say 500. These numbers representing earlier inputs. And then I want to highlight the resolver as well. We talk about vehicle control and efficiency. Having a true understanding of the rotational position of that motor using a resolver, allows us to make those claims. Not every project needs to start with the propulsion. We do offer auxiliary inverters that can be tied into the DC bus. And just to highlight some of the technical aspects, but you're looking at about 10 horsepower motor, and that of course is independent of the voltage of the DC bus, the current draw of the motor, and then other components as well. So there is no one right way to start with electrification. Every little bit helps, and we certainly want to promote that. Finally, I want to cover some lessons learned as kind of the best way to make a technical presentation functional. Integration can make or break a project. Defining the stakeholders and their responsibilities early, make sure that's nothing missed, and allows you to hit your time and budget more accordingly. When you're choosing a power source, you got to look at the environment or the application duty cycle to understand what's best for you, what's best for your customer. And when you choose a powertrain provider, it should be independent of that power source and should function in either situation. System efficiency is key to achieving acceptable ROI. Direct drives offer superior energy conversion as there's no mechanical transmission. Then that affects both regeneration and the propulsion operation, which is certainly very important, but that's not always the case. The application may demand additional gearing. You're not going to utilize the traditional mechanical transmission you would find in normally, as these higher gear counts are just unnecessary. They're wasteful. We have higher torque at lower speeds. So talk to your propulsion supplier. We can take your vehicle requirements and specification and really understand, can we do it with the direct drive? What can we do with the direct drive? And if we need to bring in a transmission to help you select one that really gives you the best bang for your buck. With that, I'll certainly look forward to, thank you everyone for having me on. Look forward to answering your questions, and I will be passing this back to Ray.
Thanks, Kyle. Just to reconfirm that everyone can see my screen again.
Yes, you're not in presentation mode, but absolutely.
Hey, thanks, guys. When we were changing screens earlier, I lost some functionality of the slide deck, and I have two screens going, and I was fighting the technology all the way through the previous deck. With having switched back from Kyle, I now have the deck in the right position. So thanks for your patience with me. I get the opportunity today to speak to you about infrastructure related to electric vehicles. And there are some technical pieces to the next part of the presentation. But we're starting off with a bit of an overview, and I can share with you, based on my 15 years in the zero emission vehicle space, Siemens has a global leader within the electric infrastructure vertical. And I think everyone acknowledges that this zero emission electric vehicle space is moving fast. And what's happening is this organic growth where somebody gets ahead in Europe, we learn from that experience in North America, and then we leapfrog Europe and the technology goes back across the pond. So it's been this really fun experience and cultural even within Siemens, where we have established the position of Siemens as what we call, our tagline is plug to grid. And if you remember anything from our technical presentation, I would ask you to remember this, that Siemens as a company provides plug to grid solutions for electric vehicle infrastructure. And what I mean by that is that Siemens is involved at the very front end where we help customers evaluate how to electrify. And I'll give you a small example of that closer to the end of my presentation here. But we're also involved in site design and layout, execution, installation, and commissioning of equipment. And of course, Siemens has a design, finance, build, own, operate, and maintain model related to infrastructure. But most of the time that I have with you today is going to focus on the supply side of the business. I'm going to talk to you a little bit about chargers, but most from the perspective of socializing the charger concept with you and giving you some physical examples of what chargers actually look like. So the main purpose here today with respect to chargers is to give you a little bit of information about chargers themselves, talk to you a little bit about the grid and the energy related to delivering electric vehicle performance, and then talk a little bit about a thing the industry acknowledges as microgrid. And with that, I just would like to close out one trend in vehicle electrification, and that's regarding the hardware and software standards that really have developed across the world over the past, say, 10 or 15 years. And in Canada particularly, we have here on the left-hand side of the screen an image I got offline, but it highlights a Siemens charger and a New Flyer bus. So I thought it was good for this session, where an organization called Qtric in Canada has helped industry establish interoperability. And what I mean by that is that a Siemens charger or a competing charger can deliver energy to the same bus seamlessly, and vice versa. Different buses can accept energy from those same chargers. So that is hardware and software driven. And when we are talking about software in the electric vehicle business, we really are designing things to what we call OCPP, and these are open protocols. And rather than reinventing the logic wheel every time a new software is provided, these standards sort of guide the process and don't pigeonhole clients into, say, a beta or VHS kind of thing. The physical standards as well, I mentioned the J3105 standard here. It is the heavy duty, high energy charging standard, but there are other ways to get a lot of energy at once. And I'm pointing out these plugs. This really could be an entirely separate presentation on just the plugs themselves. But the point is that there are standards for various energy levels and voltage levels, and this is what those look like. So primarily this slide is to let you know about the standards that already exist and give you a bit of a snapshot about what these chargers look like. And of course, we happen to have a sale today on all of our chargers, so I have an order book ready for the end of the Q&A. But the purpose of this slide is really to highlight again for you what the different chargers look like and to provide some confidence that Siemens has a complete portfolio of chargers. And with this slide, you can see on the left-hand side a charger that you might find in your home garage for your own personal automobile. It's a relatively low energy charger. It's fully capable of charging your car. And physically, this is what it looks like. Beside that is what we call a DC fast charger. And some of you may have seen Tesla-style chargers in parking lots across the country. There's maybe a dozen or so fast chargers. People pull up to these. You might have seen them in some hotels. Interesting story about Sun Country Highway, if you've seen any of those chargers. But Sun Country electrified the Trans-Canada Highway about 10 years ago with chargers for free, and they have a business model related to that. But these are sort of how to charge personal vehicles very fast. And then we start moving into our equipment range. And you know, some of the lighter duty vehicles might deal with DC fast chargers and the plug-in styles that I described earlier, but fire trucks, mining equipment, buses, heavy equipment like that, we would classify as medium and heavy duty chargers. And we get into some very large charger cabinets, 600 kilowatts here. And then we have dispensers, say 150 kilowatt dispenser. So some of these lines are liquid cooled, some of them aren't. Some of them can be delivered on street with what we call a pantograph. And there are garage depots now where pantographs are roof mounted. So really the purpose of this slide is to give you a snapshot of what these different charger systems look like. Not for nothing, there is a little bit of work that does go on behind the charger scene. And really, we'd just like to inform you that Siemens has this hardware and the ability to install it. I mentioned the plug-to-grid solution. And really, when we start talking about more than pilot or test fleets, this is when this kind of equipment starts to be required. So anything, say, over 10 or 20 heavy-duty vehicles, we need to start looking at things like transformers and switch gears, and then interface the chargers to that equipment. And of course, we've got that capability. A quick note on software, and I will talk about software mostly for the rest of the presentation because it's so integral to the operation of a fleet of vehicles, not necessarily required for your personal automobiles, but we at Siemens has developed a variety of different charging packages that are on a subscription basis, and really these software packages are designed to help the clients manage their fleet. And most of the rest of my presentation talks about how we approach fleet management from a charging electric vehicle perspective. Understanding that I'm starting to bump up against the time clock a little bit, I'm going to abbreviate this by saying that we as a company and an industry have gone through a learning curve related to the rollout of electric vehicles. And the original approach of industry and really everyone with respect to electric vehicles was simply to buy one and connect it to the grid. And what I mean by that is connect the charger to the grid, then the charger to the vehicle. And we know that that is absolutely the most expensive way to approach electric vehicle infrastructure. And I just spent a little bit of time talking about software and really giving you a simple example from the transit business. A customer's fleet of buses will roll in at night. They'll experience a charging event and then roll out the next day. the point of the transit example is that the bus on its return to the garage does not have to necessarily charge from 0 to 100 immediately. The point is that we can manage that charging sequence over the course of time with software, because we'll know, for example, that the vehicle doesn't pull out until 6 a.m. the next morning. So with that software, we're able to actually plan charging events and reduce the peak energy consumption. And by reducing the peak energy consumption, we also reduce all of the capital equipment required to get to that peak. The next step in the fleet electrification process is to employ a thing that we call a microgrid enabled smart charging system. And I'll speak to you a little bit about microgrid here in the next slide or two. But really, this essentially enables a fleet operator to generate some of their own power. And this is what a microgrid looks like, metaphorically. So the basis is that the client has a fleet of vehicles. I'm a bus dude, so I say buses, but of any electric vehicle, they have a fleet of electric vehicles. And potentially, they have local renewables, so say solar or wind. They probably have a legacy backup generator for their depot or their ongoing operations, even if it's a backup to simply power their diesel pumps when there's a power outage. This is where we can connect that same generator to the microgrid controller to be able to supply energy, say, to an electric vehicle. So this is really illustrating the concept. And as the client's fleet grows beyond 10, 20 vehicles into larger energy consumption, this microgrid system becomes increasingly important, where a client might deploy battery energy storage systems so that they achieve energy optimization. And what I mean by that is that they optimize their energy costs. They optimize their own power generation, whether it's the diesel generator, the existing diesel generator, or whether it's new solar deployment. So this is the concept behind microgrid. And of course, we're available for questions on that. Ron, how is our time? I have a couple of more slides. I don't need to cover them.
I think we're doing pretty good. Why don't you continue?
Okay, thanks, Ron. So with respect to microgrid, I would just elaborate a little bit on the software. I talked about a microgrid controller. It really is a human-machine interface that decides when is the best time of day to draw energy from the grid, when is the best time of day to draw energy from the batteries, what is the most logical way to charge the client's fleet. And this is how the energy management cost is optimized across the spectrum, from reducing the amount of capital to optimizing the actual energy consumption of the client. And I talked earlier a little bit about Siemens Consulting, and this is sort of what that looks like in, say, the most simplified example. And what I'm trying to describe on this slide is how to optimize the number of charging points, CPs, to electric vehicle, the ratio of those chargers to vehicles. And so we create a profile of the user. What is the duty cycle of the client's equipment? And what is the charging strategy? And I go back to my bus example because I do know that best. Primarily the client's charging their buses overnight. That might not necessarily be the application of your clients where they have overnight to charge their fleet. So that's what I mean by charging strategy. When are we trying to charge the vehicle? And referring back to David's digitalization discussion, we are able to run what we call a digital twin. And what I mean by that is we're able to run charging simulations based on the number of vehicle chargers, based on the number of vehicles, and based on when and how much energy we can deliver to those vehicles at any one time. So this is what we call the digital twin, and it gives us a snapshot of whether our strategies are adequate to maintain the operation of an electric vehicle fleet. And when we go beyond that, when we take the consulting offer beyond that, it starts to touch the microgrid version. And what I mean by that is after we run the digital twin, after we determine the energy consumption, what time of day, we then take a look at the energy supply. When is the most expensive time? When is the cheapest time to procure energy? And what are the options available to the client? Is there a business case related to having battery energy storage systems on site? And is the business case there to support the reduction of capital cost to increase the client's grid size connection? Or potentially, is there enough savings in energy costs to justify charging those batteries in non-peak times and deploying that energy to the vehicle in peak times? And then, of course, evaluating, is the grid, are the connections, is the transmission and distribution sufficient enough to supply the client demand, the fleet demand related to supporting deployment of that zero emission fleet? So with that, I'd really like to turn it over to question and answer. But first, Ron, thank you very much on behalf of Siemens for organizing this event. And thanks to all of you participants for sharing in our zero emission journey. It's really an exciting time in our business, and I'm looking forward to the next 10 years.
Great, thanks so much, Ray. And thanks to you and Kyle and David for sharing your knowledge with us here this morning. We're going to open it up to questions here in just a second, and I'll leave it to the people at Siemens to figure out who best should handle the question. One question I have is in high horsepower, high torque applications. Take a large agricultural tractor, for instance. The practicality of having enough storage, energy storage on board to drag a large cultivator through a field is something that just isn't practical. But a path to electrification may be the electrification of parasitics. And Butch had asked or had a question in regards to running electrical power to a trailer, or perhaps in precision ag, electrical energy to an implement to be able to more precisely plant. Is there any stories that Siemens can tell of companies that have maybe taken a road to electrifying parasitics and then moving to full electrification?
Hey, Kyle, I'll look for you on the actual equipment side of the business, but Ron, what you're really describing is what we call, what the industry has termed a mild hybrid, and that's sort of what I was referring to when I talked about low-hanging fruit at the onset of the trends section. My own personal experience, I did dive right into zero emission vehicles, but after that I did consulting work where we pulled primarily diesel propulsion products into the electrification by electrifying components. And what I mean by that is things like air conditioning, other loads like stop start, for example, by implementing supercapacitors to help. And what industry finds is that there are a number of other maintenance problems solved by introducing electrification. So for example, electric AC is more reliable than conventional AC. The stop-start mechanisms, there's a number of the lower voltage batteries going dead in fleets for a variety of reasons, especially in Canada with the cold. And when you implement things like a supercapacitor, you eliminate calls in the morning, no starts, while at the same time enabling stop start, which obviously reduces fuel economy. Taking loads off the engine obviously increases fuel economy. So the point about mild hybrid can be rolled out across the accessory package and relatively easily, relatively low cost, and the business case is absolutely there.
Okay, I'd never heard that term before, mild hybrid.
Yeah, you know, the zero emission folks really are way over on the right hand side, and I do find myself personally somewhere in the middle, but I'm more into making money. I'm more into that sustainability graph, and reducing carbon just simply is profitable. So
Yeah, more of a practical sustainability.
100%.
Great. Okay, I don't see, is there any other questions? Feel free to use the Q&A feature. If you have any questions for our presenters, we'll leave it open here for a couple of minutes and see if anything comes up. Oh, I see something come up here. Okay, this comes from Bob Parsons. Charging power levels represent a bit of a trade-off between cost of vehicle versus cost of charging system. Are there any trends Siemens see on breakpoints in moving to higher power levels? Also, especially for HDV&E, demand fees from utilities are pretty complex and critical. Any insights?
Yeah, what a great question. So you're opening up a conversation about the electricity market, and this is true across North America and Europe, where the electricity market changes from province to province, state to state, country to country. So the business case that you're referring to, I will break into two pieces. First, the energy market, and second, the charging rate. So the electricity market and the business case related to the implementation of electrification changes from those locations, and the demand charges also change from those locations. I'll just give you a simple example. In Ontario, we have factories like concrete manufacturers, steel makers, who deploy battery energy storage systems to take themselves off the grid during the period when they incur demand charges. And there is an amazing 3-year business case related to that. Now in Ontario, demand charges have been grandfathered during COVID, but the fact is there's a business case just in the demand charges. But what you're talking about in terms of energy via charger to the vehicle is a little bit more complicated, and that's why I started talking about smart charging software. And it really, we need software. When you get over 20 vehicles in a fleet, it becomes difficult to manage the charging sequence manually. So we depend on charging software to sort out for us how much energy to deliver a vehicle and when. And that will often involve interfacing to existing onboard vehicle technologies. So there's already technology on vehicles that, say, provide GPS coordinates. What we want to know from a charging perspective is what is the duty cycle next, so that we can plan to provide enough energy to meet that duty cycle next. And then that controls the amount of energy delivered by the charger to the vehicle. So hopefully that gives a snapshot into a reasonable answer to that question.
Okay, thank you very much, Ray. As an add-on to Butch's question in regards to parasitics, and running a parasitics electrically as a path to mild hybrid, Kyle, how practical is it to have 50 horsepower of electrical energy available to run parasitics in a situation like this?
I think it's definitely very available. And just looking at the 3 counts at those horsepower ratings, it's certainly not anything that's abnormal in terms of auxiliary loads. I want to take the asterisk of needing to understand the voltage level and the current draw of those motors, but from my perspective, it would be very easy to have a one central inverter, which provides the, I guess, your DC bus, and actually has the controller that allows us to manage that energy. And then from there, connecting 3 auxiliary inverters, which I believe can handle up to 20 horsepower, depending on that amperage drop.
Okay, so completely doable.
Yeah, I think that's certainly a big part of electrification is once you put that main driver on an electric system, now you have an eco infrastructure that you can then use to apply to the auxiliary loads.
Excellent, thank you. Glenn Naylor is asking about V2G. There was very little discussion about V2G. Is Siemens ready for this, and how fast will it happen?
I'll take that one. This is Ray Little. V2G exists, but more from a living lab perspective. At home, so the home version of the charger that I showed on our slide, it is capable of V2G. And I would say that that's limited in application. There isn't a lot of energy being traded there. From a medium and heavy duty fleet perspective, vehicle manufacturers are most concerned about the life of their batteries right now. So they are not including V2G on their vehicles. And again, this primarily relates to the duty cycle experienced by lithium ion batteries on heavy duty vehicles. It really is hard on the battery. But when we get to the energy storage side of the equation, dealing with fleets, that's where the microgrid conversation comes in, and selling energy back to the grid. The duty cycle on the wayside batteries is not nearly as severe as a heavy duty vehicle. So I see more market developments related to microgrid as compared to V2G.
Excellent, thanks, Ray.
I did actually see, I just want to add, I was at a conference, and one of the transit agencies did a study on vehicle to grid, and it actually proved the concept. They were able to read on both sides of the meters, and were able to actually generate nearly $5,000 of revenue from one of their buses. So I think it's to what Ray's point is, the microgrid concept versus vehicle to grid is much more complicated than a simple proofs of concept, but it does represent something that is potential.
Yeah, it's interesting you mentioned that. I was down in South Carolina at an automobile conference, and there was talk in regards to electrification of school buses, and with school buses not being used in July and August, and then having huge air conditioning loads on the grid in July and August. The thought was, of why couldn't you use the buses as energy storage for peak capacity when it came to high peaks on the grid, which I thought was rather interesting because they're just sitting there anyway.
Absolutely, I think the rolling blackouts or brownouts is one of the more interesting environments in which vehicle to grid might really make a big difference.
All right, Dean Richardson's asking, what are the possibilities for retrofit in existing fleets? How would a fleet operator start the transition?
Yeah, so let's looking at like a bus. I understand there is almost a mandatory midlife refurbishment that you see on the conventional vehicles, an opportunity to perform the significant maintenance and upgrades, and just getting the vehicle back for another 7 years. We're absolutely facilitating requests in the industry for taking that opportunity to refurbish or convert conventional buses to electric buses. The idea being that the price point is lower than a new bus, and the time to market is lower as the vehicle has an already planned, I guess, time not in the fleet, and it doesn't take as long to get a new bus. Regarding the transit agencies, I would say you want to work with a refurbisher who has this experience or is approaching this market. One of the challenges being that the conventional diesel chassis and the body is not necessarily prepared for a potentially larger or heavier electric system, or where do you place these things? The motor or the batteries may be placed in positions that you would not agree should be placed on the chassis, and how that affects the vehicle driving capability. As well. And another issue that I remember talking with the transit agency on was who takes the ownership of the liability now that this bus is not the same as it was before? And are you refurbishing these buses to the current industry standards? It's very, very new market. Certainly one that I think is very interesting. I think if you are a fleet operator and wanting to really take advantage of this, you should definitely involve a refurbisher that you're very comfortable with, and really try to drive home a schedule, a commercial outlook of buses. And I think that business forecasting would absolutely allow someone like myself to align ourselves in production capability, software capability, and then you probably need some time component to make sure that there are prototypes in place in the vehicles that you want to have refurbished that meet what you expect in terms of operation.
Yeah, those are all really valid points. Sometimes with something as radical as a change to electrification, there was a discussion about this yesterday. It may be better to start with a clean slate, because then you can optimize battery storage locations of components, routing of critical cables, and all that sort of thing. So, the retrofit route can be a very windy road.
Absolutely. And I'm in conversations with chassis people who focus on designing new chassis that are better equipped to handle the electric vehicle components.
Mm-hmm.
So it's
Hey
definitely
guys,
a very, very complex.
Hey,
Good.
thanks. I would just add that probably the opportunity for retrofits lies in the auxiliary power components. And I'm not sure, I don't remember who asked about the 50 horsepower range, but that's what I'm talking about. That's what I'm referring to. So I see it as and depending on the life cycle of your vehicle, I'm assuming all are light, medium, heavy duty folks on this call, so not personal automotive. But electrifying auxiliaries, I think, is a huge opportunity for service revenue and a huge opportunity to move the needle on carbon related to auxiliaries.
Excellent, excellent. Bob Hastings is asking, what's the forecast timeline on fuel cell systems as a replacement for battery type energy storage? Is this hydrogen distribution system dependent? Many of the hybrid issues disappear with fuel cells.
I love fuel cells. My personal read on the market today is that fuel cells are a complement to electric vehicle technology and energy storage. There's still fairly substantial cost related to hybrid stations, and you would describe this as an on-site station if you're replacing energy storage. But I do see it as complementary, at least for the next 10 years. I'm not sure after that. Everything changes in zero emissions so darn quick.
Yeah, definitely agreed. A conference I attended, they really, I think the takeaway for me is that each energy source has its best fit. I know that one webinar I attended brought up hydrogen. We're calling hydrogen the true renewable resource based on its ability to be generated in so many industries and then applied. They're very, I'll just go ahead and say it's very circle of life in how hydrogen is built. Right now, fuel cell systems are more expensive, but that's certainly a price point that could come down. I think you do bring up a good point that some of the hybrid issues do disappear with fuel cells. And the way I would describe that is fuel cells have the ability to have a longer range than hybrid. So looking at a presentation from a Long Beach Transit Authority, their plan is to have a mixture of both, having battery vehicles for the more of a milk run route, more circular, more consistent, and then also having fuel cell vehicles that handle the longer routes, or even specialty trips. So thinking about a school bus going on a school trip, the fuel cell might offer a better range and a more comfortable range to make that trip and back. So I think there is no I don't think there is a immediate time in which one is better than the other. I think that we're also need to incorporate overall funding opportunities and regional preferences. You know, an oil and gas region might be more leaning towards hydrogen than a less oil and gas based region. And then each fuel source benefits the vehicle performance indifferently.
Yeah, and the interesting
Yeah.
thing with fuel cell technology, like especially with vehicles operated here in Canada, is we need heat in the operators' compartments, and one of the byproducts of a fuel cell are heat. So it's almost a little bit more of a natural, because otherwise, what you're doing is you're spending your stored energy to heat occupant compartments, which is basically degrading range, right?
Absolutely.
100%. Yeah.
Absolutely.
So just to be clear, I originally interpreted the question about on the wayside energy storage as compared to on the vehicle.
Mm-hmm.
And just like Kyle said, there are fuel cell electric vehicles as well as electric vehicles, and you know, the whole complementary piece, getting to zero emissions, reducing carbon. It's a combination, especially to extend range.
Okay. One last question, I'll ask this one, is what future energy storage technologies is Siemens tracking? Are you interested in that may be out there, maybe even quite a ways out there, that you see as a potential light to solve some of the weight issues in regards to energy capacity versus range and other, energy storage size, impinging on occupant compartments and things like that? I'm just curious as to what do you see out there in the future that might be quote unquote interesting?
Go ahead, Ray.
I was in the lithium-ion battery business for a little while, and there was talk about zinc air style batteries. There needs to be a leap from lithium-ion to the next gen that is equal to the leap from lead acid, nickel cadmium to lithium-ion for that to happen. And I believe actually that probably the next technology is existing, but at the military level right now. It's high cost, it's high experiment. So I think the next generation of battery is there, but not to be adopted yet. Fuel cells, I really like the question about the fuel cells. I really do see that as potentially, you know, the worldwide solution 25, 50 years from now. But I also see a substantial battery still being a complement to fuel cell. Kyle, what do you think?
I guess I definitely agree that I'm look at fuel cells as the best solution, and certainly the longer term being able to really get the value out of it with range. But I also agree that batteries have their fit, and I think as we understand route types, I think that's really where we're going to see some innovation in how we approach this market. As we always think about the gas pump or the fleet depot and the return to the fleet depot. I know Siemens is certainly investing in the opportunity charging mindset. I think I had a very small picture in one of my slide decks, but essentially being able to connect to a vehicle using a pantograph at strategic locations might be the way of the future. As in our e-highway group, they've actually set up a pantograph system that connects to the tractor or the truck itself, and then runs along the highway, similar to a tram or a train. And so, if I had to point at something that would really create some disruption, I think having the ability to recharge or put power back into the vehicle without having to return to home base is really where we'll see a big difference.
Well, that's great. Well, it's 11:30, and we committed to being done in an hour and a half, which we have. But thank you very much to Ray and David and Kyle for presenting today, and for Roberta for coordinating this on Siemens' behalf. Roberta is located here in Manitoba, so if there's questions in regards to what Siemens could possibly do, you can send information to me and I'll connect you with Roberta and for further discussions. So with that, I thank you all for your time and for sharing your expertise with us. Thank you very much.
Thank you, everyone. Have a nice day.